Okay, good evening. Welcome to Math for Kids number
60!
60. Awesome, awesome, awesome. Okay, you ready?
Yep.
Okay, consecutive integers are integers that follow in order, like 3, 4, 5, and 6. Okay, so does that make sense? Do you know what consecutive integers are? Okay, find 3 consecutive integers whose product is 9,240. Whoa.
How are we gonna do that?
Yeah, how are we going to do that? 9,240. Okay, do you have any ideas?
Not really.
Not really? Okay.
What should we do?
Well, there's a couple of different things we could do to try to do this. You know what really sometimes helps if you're trying to find numbers that multiply to be another number?
What?
Factor it into primes.
Factor 9,240 into primes?
Yeah. So do you know any numbers that go into 9,240?
10.
10, okay, so it's 10 times 924. Okay, that's good.
924 is 2 times
Okay.
462.
10 times 2 times 462. Okay, that's good to know.
Which is 2 times 231.
2 times 231. Okay, that's awesome. Good factoring so far.
Okay. Anything going to that?
Anything going to 231?
Some of the digits is 6.
Some of the digits is 6. Okay, so what does that mean?
It's 10 times 2 times 2 times 3.
10 times 2 times 2 times 3 times, well, 3 times 80 is 240. So that's 9 less than 80.
So it's 3.
Sorry, it's 9 less than 240, so it's 3 less than 80, which is
77.
okay, 77. So this is 10. Well, we may as well factor the 10, by the way.
It's 5 times 2.
Okay, so we got 2 times 5 times 2 times 2 times 3 times
7 times 11.
7 times 11. Okay, so that's actually going to be really helpful to try to figure out what 3 numbers we're going to use.
Ah!
Okay, so
We could just use these.
well.
No, they're not odd. Whoops, they're not consecutive.
No. Now, I just wanted to tell you that 2, 10, and 462 are not consecutive. They're not. Because you know what comes after 2?
3.
Right, not 10. And do you know what comes after? Do you know the next number that comes after 10?
Yes, 11.
11, right. Are you sure it's not 462 that comes after 10? Yeah, it's definitely not. Okay. So, now that we've factored this number into primes, 9,240, when we find our 3 consecutive integers, we're going to have a multiple of 7 and a multiple of 11 and a multiple of 5. So, and a multiple of 3. Now the neat thing, the nice thing to use might be the 11. Okay?
Double digit.
Okay. Well, just because it's the biggest one. So we might want to check multiples of 11. So do you want to check like 11 times 12 times 13? Would that work?
Well, 11 times 11 is 121.
Well, 11 times 12 times 13. Let's just see what that is. Oh, I see why you're doing 11 times 11. Okay.
Plus 11, it's 132.
Okay, 11 times 12 is 132.
132 times 13.
132 times 13. Now we know this isn't going to be the answer because we don't have a 13 down here, but let's just see if this is even close to 9,240.
Well, 1320.
1320. Back up. 1320 plus
396.
396, okay. Okay, so this is going to look a lot like
1716.
1716, which is not even close to 9,240. So it's not going to be, 11 is not going to be the integer to use. So what's the next multiple of 11? Check.
11 times 10 times 9? No, that's even
No. Well, remember, right, so 11 times 12 times 13 was much too low, so we may as well go to the next multiple of 11. What's the next multiple of 11?
22.
Okay, right, 11 times 2. So now we could do a 2 times 11, and we're left with these. Now, are there any multiples of 7 near 22?
Yeah.
What?
21.
Oh, which is what?
7 times 3.
Oh, that's interesting. 7 times 3. Okay.
No.
Hey, look at that. What's 5 times 2 times 2?
It's 20.
Hey.
Wow.
Hey, look at that. Let's back up a little bit. Look at that. We just found it just by, we factored it into primes. We checked if we could use the 11 by itself. And it was too low. 11 times 12 times 13 was just way too low. Now we didn't even have to multiply that out. We could have just checked that 11 times 12 times 13 was going to be kind of close to 10 times 10 times 10, which is 1,000, which is way far away from 9,000. Now this is going to be a little bit more than 10 times 10 times 10, yeah. But it's not going to be, 9 times farther away. But so when we used the 2 times 11, then we noticed, oh wait a minute, we were going to need to use a 7 also.
And we could.
And we could use 7 times 3, and then we used just the rest and gave us 20, 21, 22. That's pretty neat. That's a neat use of factoring, isn't it?
Yep.
Okay. You ready to go to the next problem, or do you want to doodle a little more?
I'm going to go to the next problem.
Okay. Okay, here's the next problem. The average of 1.5, 2 1/3, and x is 3. What is x?
I forgot a punctuation mark both times.
I forgot the punctuation mark. I'm sorry about that. The average of 1.5, 2 1/3, and x is 3. What is x? This is an interesting average problem.
Well, we know...
Remember what average means?
Yeah, we sum up the numbers and divide it by the number of numbers.
Okay, so that means 1.5 plus 2 1/3 plus x divided by what?
Divided by 3.
Divided by 3 equals
3.
3. Okay.
Well, the sum must have to equal 9.
Okay, so that means that's exactly right. When you divide by 3, you get 3. So that means the sum actually equals 9. Okay.
Well, 1/2 plus 1/3.
Why don't you go from there?
1/2 plus 1/3. Well, 1 plus 2 is 3. Plus 1/2 plus 1/3 is 5/6.
Okay. You want to write something down?
Yeah. We have 3 and 5/6. 3 and 5/6. So far.
Hold on one second. Here. Just write it over here. So 1.5 plus 2 1/3 is what? No. Just write it underneath. Like write it right here.
Oh, this is 5. It's 3 and 5/6.
3 and 5/6 plus x
equals 9.
9. There you go. That's what I wanted you to
Well,
write. So 3 and 5/6 plus x equals 9.
That means it's 6 and a 1/6. Well, 3 and 5/6 plus 6 and 1/6. That's not 3 and 5. No, that's actually 10. So it's plus 5 and 5 and 1 and a 6.
Plus 5 and 1/6. Okay. So how did you figure that out?
I did 3 and 5/6.
Scoot over a little.
Plus, I know there would have to be 1/6 included.
Okay, there would have to be 1/6 included.
Well.
So when you add 1/6, what do you get to?
You get to 4.
And then how much more do you have to go?
You need 6. You need 6. No, you need 5 more to go.
You need 5 more to go. Okay, so 3 and 5/6 plus what equals 9? Plus
5 and 6.
5 and a 6 equals 9. Okay, hey, good job. That was really nice. Okay, so what we needed to do on this problem is we needed to know what average meant. And average meant add these 3 numbers and divide by 3, and you get 3. Which is the same as when you add them up, you get 9. Right?
Yeah.
Okay, and then you just combined the 1.5 and 2 1/3. You know that 1 plus 2 was 3, and 1/2 plus 1/3 is 5/6. How did you know 1/2 plus 1/3 was 5/6?
I think that was the first adding fraction I studied, with the denominators, actually.
Oh, awesome. Okay, great. So we had 3 and 5/6 plus x equals 9. That means x equals 5 and 1/6. Very good job. Okay, and these problems were based on Olympiad 25, problem number 3, and problem number 4. Good job, sweetie.